So we're going to talk about how limits involving infinity, okay? So for limits involving infinity, I'm just going to talk about a question here. So limit x approaches infinity, and then function 2x squared minus 1 over x squared plus 3, okay? So how do we do this, okay? So don't look at the solution first. We're going to walk you through this. So this is called a cutting method, okay? So when you approach infinity, it's actually really hard to just use substitution or any of those stuff. What we're going to do is first, let's write the equation out. What we're going to do is we are going to divide both sides by x squared. So when you approach infinity, we always get like the biggest x denominator possible. For example, if we have 2x to the 3 minus 1 over x to the 3 plus 3. So you get, for this one in case, you divide by x over 3. So in this case, it's just the coefficients 2 over 1, okay? So just easy way to remember, when you approach infinity, take the coefficients. It's 1, so you get 2. And finally, I'm going to talk about asymptotes. So asymptotes is just, for example, we have y equals to 2. And then so this should be limit as y approaches 2. Because this function right here, fy, function should be limit as y approaches 2. So 2 is the horizontal asymptote. Okay, so these are just some practice questions, and you can look over the answer keys right here. They're all pretty easy, and yeah, this one here, for example, it shows my cutting method. Right here, because it approaches negative infinity, so negative 3 over 1, right? So that is negative 3. The method I just told you right here, the coefficient method. Same as this one, approaches infinity, so it should be just 3, because 3 over 1, coefficient is 1 right here, so it should just be 3, and yeah, that's basically it for today's class. And here I just want to make a summary right here, okay? So make a small summary down here, okay? So in this class, we talked about the 2 important limits, okay? So the 2 important limits are separately, number 1, we have, number 1, we have a limit as x approaches infinity, sine x over x equals to 1. And 2, as cosine, as limit x approaches infinity, cosine x minus 1 over x equals to 0. And then here, just one more. Here, limit as x approaches infinity, tan x over x equals to 1. And we just talked about the squeeze theorem. And finally, we also talked about the limit as approaches infinity. Limit x to infinity. For example, we just use the cutting method like this. 3 over 1, 3, right? So yeah, that's it for Unit 2, and I'll see you in Unit 3.